So let's talk about epoxidation, and it's one of those reactions I find so fascinating because we talk about it so much, but if you work practically in the lab, what we're going to work with are peroxides, and those are super dangerous. So we're talking about a reaction where you work with a compound that most people want nothing to do with it. So peroxides contain an OO single bond within them. So an example of this is hydrogen peroxide, H2O2. You got your oxygens, hydrogens, and they form a single bond. Now, the bad thing about peroxides is they like to dissociate to give free radicals, which is why we don't like them. They're incredibly unstable and they are dangerous to work for. And typically we don't store them in pure forms. They're usually stored in solvents to kind of reduce how dangerous they are. The way we identify a peroxide is RCOOH. So a carboxylic acid, usually we designate with RCOOH because a carboxylic acid looks like this. Your peroxide has an additional oxygen in there, so it's in that carbon chain. So when we see an R, C, 3 O's, H, we are working with the peroxide. What the peroxide is going to do is it's going to take our double bond and it's going to add an oxygen to it. Now, this oxygen is added to the same side, and you can kind of see this if you build an epoxide with your model kits. But the oxygen has to be on the same side, so typically we'll draw this with a wedge or the dash, but we do need to specify that it's coming out of the board. So this oxygen sits between the carbons, and these epoxides are fairly unstable. I mean, they exist at room temperature, but they're fairly reactive. They're fairly reactive compounds. That's the better word for it. So when we do a peroxide addition to an alkene, what we end up getting is an epoxide, and this is a carbon-carbon oxygen 3-member ring. This oxygen is added on top or below the double bond, but the point is here that if we create any type of stereochemistry, typically we view it as the oxygen pushing down the groups. So the hydrogen here is going to be down, and the hydrogen here is going to be down. And if we have any type of stereospecificity associated with this molecule, we are going to need to add this in. But again, the nice thing about peroxides, it's a syn addition, so it's pretty easy to figure out where the groups go.